Okay, number 2, tan of 7 pi over 12. So 7 pi over 12, we're going to start the same as we started number 1. 7 pi over 12 is in the second quadrant. Unlike 5 pi over 12, it's just a little bigger than 6 pi over 12. So we have to remember where tangent is positive. Tangent's positive in quadrants 1 and 3. So we're going to expect a negative value here as our final answer. So I'm going to go ahead and recopy tan 7 pi over 12. And we're going to find two values that we know on our unit circle that will add to that. So if you haven't yet, pause the video and see if you can find those values that you want to use. All right, hopefully you found those values. I tried 1 and 6. 6 pi over 12 will reduce, but pi over 12, we don't know a value for that. You can try 2 and 5, but unless you want to use the value that we just found for number 1, we don't know the value of 5 pi over 12. It's not a nice one to work with. So I'm going to use 3 pi over 12 and 4 pi over 12. Those are nice ones. Very nice values, because 3 pi over 12 is going to reduce to pi over 4, which we like quite a bit. We like working with tangent of pi over 4. And 4 pi over 12 is going to reduce to pi over 3. So if you were able to trudge through number 1, number 2, the math was going to end up a little bit easier. So put this into our formula, tan of the first plus tan of the second, all over 1 minus tan of our first times tangent of our second. Tangent of pi over 4 is 1. Tangent of pi over 3 is radical 3. 1 minus. Tangent of pi over 4 is 1. Tangent of pi over 3 is radical 3. Again, at this point, I would pause my work and double check any of those values that I'm not sure of. Tan pi over 4. Hopefully you have that one memorized, but just for confidence here, tan pi over 3. Well, let's make sure that's the same as radical 3. Whoa, not radical 63. There we go. So those two right there, 1.732 approximate match. And we just need to clean it up and rationalize here. So a little shorter than the last problem. Remember, we're always using the conjugate. So in the denominator for this problem, we have a minus. That means we're going to multiply by 1 plus radical 3. Both ways. And FOIL. Double distribute, whatever you want to call it. Radical 3 times 1 is just radical 3. That happens twice. Radical 3 times radical 3 is 3. Or square root of 9, which is also 3. Or square root of 3 squared. In the denominator, I'm going to go ahead and multiply everything out as well. Be really careful with your signs here. Negative radical 3 and the positive radical 3. We designed the problem to work that way, because we want to get rid of the radicals. The other thing to be careful about there in the denominator is that sign in front of that constant at the end. Negative radical 3 times positive radical 3. So you have a negative 3. Okay, combine our like terms. Remember, our like terms, we have our whole numbers, our integers. 1 plus 3 is 4. And then we can add our radicals. They work like variables. I have one radical 3 and another radical 3, so I have 2 of them. My middle terms here cancel. Again, you have to be really careful with your signs here. 1 minus 3 is negative 2. I'm going to say again, be careful with your signs on your division. 4 divided by negative 2 is negative 2. 2 radical 3 divided by negative 2 is negative radical 3. The other way to write that might help you is to break that up. Divide both by negative 2 separately. Break up that common denominator. All right, let's check it. So we said that this is tangent of 7 pi over 12. I'm going to make sure I get the same ugly decimal for both of those values when I put it in my calculator, and I do. Awesome.